Swayam Prabha. Digital India. Educated India.
Remember, H12 is multiplying a voltage V2 to give you a voltage V1. Okay. So what are the units or dimensions of H12? So clearly it is dimensionless or unitless. Okay. Similarly, what is it for H21? Units and dimensions of H21. Someone answered mho or Siemens for H12. That is not correct. So units or dimensions of H21. So again, H21 multiplies a current I1 to give you a current I2. So this is also dimensionless. Okay. And finally, what are the dimensions of H22? H22 multiplies V2 to give you I2. So what are the dimensions or units of H22? So H22 multiplies a voltage to give a current. This clearly has dimensions of conductance or units of Siemens. Okay. So the point is, in H parameters, the four different parameters have different units. Okay. That's why these are known as hybrid parameters. Okay. So the next question is, let's say I want to measure H11 and H21. Okay, H11 and H21. So what should I do to port 2 in order to measure H11 and H21? Couple of you answered that port 2 is open circuited. Please explain why it should be open circuited. And there is another question, will H12 equals H21? That's actually a very interesting question. We will take that up shortly. Okay. So clearly, when you are measuring H11 and H21, in general, parameter 11 and parameter 21, you have to set the independent source on port number 2 to 0. Okay. So in this case, we have to set V2 to 0. Now, what happens if V2 is 0? What does it mean? Is it open circuited or short circuited? So clearly it is short circuited. If you set a voltage to be 0, so that means that it is short circuited. Actually, there is some confusion here. Somebody responded saying in open circuit voltage will be 0. That's not correct. If you have an open circuit between 2 points, there can be any voltage between those 2 points, but there can be no current. Okay. So a 0 voltage means a short circuit, 0 voltage source, and a 0 current source means an open circuit. Okay. So clearly, to measure H11 and H21, I have to short circuit port number 2. Okay. So H11 is V1 by I1 with V2 equal to 0, and H21 is I2 by I1 with V2 equal to 0. So H11 is nothing but the resistance looking into port 1 with port 2 short circuited, and H21 is nothing but the current gain, the ratio of current in port 2 to current in port 1 with port 2 short circuited. Okay. Similarly, let me copy this over. So the next thing is the obvious extension of it. What should I do to port number 1 to measure H12 and H22? What should I do? To measure H12 and H22, I should do something to port number 1. What is it that I should do? Clearly, I1 should be set to 0. Now, what does it mean? Port 1 is open circuited. Okay. Okay. So H12 is V1 by V2 with I1 equal to 0 or port 1 open circuited, and H22 is I2 by V2 with port 1 open circuited. Okay. So these are the definitions. You can see that the general scheme is the same for all parameter sets. The units, the quantities that you calculate will be different. Okay. In Y parameters, you are always calculating ratio of currents to voltages. In Z parameters, you are always calculating ratios of voltages to currents. And in this hybrid parameters, sometimes it is current by voltage, sometimes it's voltage by current, it's also current by current and voltage by voltage. Okay, so everything is possible. Is this fine? Any questions about H parameter definitions? So again, there is a question on application of these parameters. So application of any parameters is the same. It is to get a compact representation of a complicated circuit. You could have hundreds of components in this, but let's say only two ports are exposed, that is two terminal pairs are exposed to you. You can describe the behavior of this entire complicated circuit with four parameters. Okay, and you could choose Y or Z or H parameters, or we'll see another one which is known as G parameters. Okay, like I said a few times before, which one you choose depends on convenience. Okay, now traditionally there are components known as bipolar junction transistors which are used to make amplifiers. So those were described with H parameters. Okay. And there is a question of why it is hybrid. Hybrid, see, if you look at Y parameters, all the Y parameters have conductances. They have dimensions of conductances. And Z parameters, all of them have dimensions of resistance. Then these H parameters, the dimensions are all mixed up. One of them is a resistance, one of them is a conductance, and two of them have no dimensions. Okay, so that's why it's called hybrid. And his last question is there any circuit element? I'm not sure of what this question means. Where are the circuit elements? So again, I would encourage you to calculate H parameters of this network. Okay, it's the same network I had earlier. So I'm not going to go through this. Please try to do this as an exercise, and if you run into any difficulty, please let me know in the next lecture. Okay. Now finally, we can also express here, we have expressed V1 and I2 in terms of I1 and V2. We can also express I1 and V2 in terms of V1 and I2. And in this case, we think of a voltage being applied here, and a current being applied to port 2. Okay, and we measure current I1 and voltage V2. Okay, so very quickly, please give me the dimensions of G11, G12, G21 and G22. What are the dimensions of G11? Clearly, G11 multiplies a voltage to give a current, so it has dimensions of conductance or units of Siemens. Okay. What about G12? G12 is clearly dimensionless. It multiplies a current to give a current. And G21? It is also unitless. Okay, it multiplies a voltage to give a voltage. And finally, G22? G22 multiplies a voltage to, I think I made a typo while writing. This is I2. G22 multiplies a current to give a voltage. So this has dimensions of resistance. Okay. So this is also a hybrid. You have conductance, resistance and dimensionless parameters. And in fact, they are the exact opposite of H parameters. Okay. So this is another set of hybrid parameters. Okay. So I won't go through this again. So you can figure out how to measure G11 and G21, how to measure G12 and G22, what you should do to port number 2 and port number 1 and so on. Okay. So I think you'll be able to do this for yourself. And also, as before, just to get some practice, calculate the G parameters. Of this circuit. Okay. Somebody answered that G22 will have no units. That is not correct. G22 will have units of resistance, dimensions of resistance. Okay. So why is the name G given? I have no idea. It's some historical reason. There was H and there is G. So I really don't know why G is given. It can be a little confusing because we use G for conductance as well. But this G in 2-port stands for some hybrid parameters. Okay. Now finally, we know that for a resistive network which is reciprocal, we saw that Y12 and Y21 are the same and Z12 and Z21 are the same. Okay. Now is there any such relationship for H parameters or G parameters? Okay. So just to refresh your memory, we discussed reciprocity for this case for I1 with this side short circuited, and we measured I2, and in the other case we had V2, we had this side open circuited. Okay. V2 hat and V1 hat, and there was some relationship between I2 by I1 and V1 hat by V2 hat. Okay, what was the relationship what was the relationship for a reciprocal network between I2 by I1 and V1 hat by V2 hat? So we derived this by putting a current on one side and a voltage on the other side. What is the relationship between I2 by I1 and V1 hat by V2 hat for a reciprocal network or a resistive network? Relationship between these two ratios for reciprocal networks. There is an answer that says both are equal. There was a slight twist. I2 by I1 equals minus V1 hat by V2 hat. If you apply Telegan's theorem and calculate the reciprocity relationship, this is what you will get. Okay. So this means that for the hybrid parameters for a reciprocal network, okay, H12 will be minus H21 and G12 will be minus G21. Okay, so they are related. H12 is the effect of port 2 on port 1. H21 is the effect of port 1 on port 2. Okay, so in general, parameter 1, 2 shows the effect of port 2 on port 1. Parameter 2, 1 shows the effect of port 1 on port 2. And in a reciprocal network, these two will be related in some way. For y parameters, the relationship is that they are equal, and for h and g parameters, they are equal and opposite of each other. Okay. Any questions about this? Okay, finally someone in the chat window commented that H11 equals Z11. Is this correct? What do participants think? Is H11 the same as Z11? So the answer is no, it's not the same, because if you think about it, V1 is H11 I1 plus H12 V2 in terms of H parameters, and V1 is also Z11 I1 plus Z12 I2. Okay, but if you look at the value of H11, it is V1 by I1 with V2 equal to 0. That is port 2 short circuited. Whereas Z11 is also V1 by I1 but under different conditions with I2 equal to 0 with port 2 open circuited. Okay, so H11 is not the same as Z11. In fact, all these parameter sets, the parameters will be different from each other. Okay, although one can be derived from the other, they are not the same as each other. Okay. So I hope that is clear. There were a number of other questions asking about details on reciprocity and so on. So we went through a long discussion on that in one of the lectures. I suggest that you please go through that lecture. If you have any doubts, we can discuss that. And then there is some question asking for books on network theorems. Books like Haidt and Kemmerly or Lin and DiCarlo are good, but I will go through the books again and then give suggestions next week. Okay. Okay, thank you. I'll see you next week.